I'm here to talk to you about cloud connectivity. How do you, as an app developer, make sure that all your users have similar, if not even better, experience reaching your application servers and web servers in the cloud? We live in a very distributed environment where users are not just on premises, but they might have their VPCs or VNets in completely different spaces than where your actual app servers reside. We solve that problem of connectivity along with performance with Riverbed and give you some visibility into your network. What you're looking at on the screen is the web console of our software-defined solution called SteelConnect. All the green checkpoints are locations, on-premises locations, where our appliances are actually deployed, except for two different locations, which is one here in Ireland, which is actually an Azure location, and the other one in India is an AWS location. So if you think about it, we're really the cloud of clouds. I've formed a connection between my Azure location and my site in AWS, and I can look at what the throughput, latency, and jitter parameters are on a real-time basis. What I will show you today in the demo is how I got here, how I actually connected the rest of my network to my cloud sites. So let's see how we do that. And I know, Keith, you've probably seen a little part of this demo previously, but bear with me. So network design and sites is basically a list of where I see all my sites. I want to connect my entire existing organization to my VPCs in AWS. And by the way, I'm going to talk about, in this demo, with reference to AWS, but the workflow is exactly the same for Azure too. The page that you see over here is accounts. It's basically a cross-account access IAM role, which gives SteelConnect the privileges to go and scan through all my VPCs and even create EC2 instances in the VPCs that I've chosen to connect to through this role. So once I do that, I can actually see all of my VPCs across all my regions and even cross accounts. So even though in this demo I have just one account connected, if you have multiple accounts connected, you will see all of that on this single page. So let's go ahead and connect to maybe my VPC in Oregon. I'm going to scroll down, and let's say I want to connect to this VPC site A. I click here on Connect, which basically creates an object as a site for me on my interface. So when I go back to sites over here, you'll see that I have one just created for me, my VPC site A. And now I can go back to AWS here and deploy an instance by clicking here on Deploy. I'm going to choose the C4 Large, and where Riverbed, Steelhead is our WAN optimization appliance for application performance end-to-end. I'll deploy a Steelhead also. And we also support redundancy because high availability is life, as we all know. So when I actually choose to deploy this, it's going to deploy it in both availability zones, both of these appliances. I'm going to skip through these two and leave this AWS routing to auto. I'll talk about that in just a second. And I'll leave the uplink to internet and click here on Submit. When I do this, what's happening is SteelConnect is logging into my AWS account. It's going to scan through all my existing VPCs in the VPC in the region that I've chosen to connect to. The next thing it's going to do is it's going to scan and look for a free/28 subnet, free/27 subnet. Why? Because it wants to now plop our gateway and our Steelhead appliance in the VPC and the subnet that you've chosen to connect to. And it breaks that free/27 into a two free/28s. So let me actually draw that real quick for you. I have the rest of my infrastructure over here. And let's say this is my VPC. And it looks for a free/27, breaks that down into /28 for my gateway. It plops it down over here. And because I've also chosen to deploy a Steelhead appliance, which is my WAN optimization, it will do all the networking automatically for me, puts my Steelhead in my downlink, and all my app servers and my web servers will now be routed through the Steelhead, be WAN optimized, and go out through the gateway and through the IGW of my AWS VPC connection, and then go out via the internet to the rest of my network.
So if you give your Steelhead like a /16, it can figure out where to put all the nodes? Or?
No, Steelhead is not a router. It sits on your LAN. And so you don't actually have to give it an address. It sits on a flat network.
What's the difference between your solution and VPN solution or a private API gateway made with OpenFiles, for example?
So the difference is that we automate a lot of this stuff for you. So while we're actually instantiating this gateway, we're also manipulating. The only thing we do is we don't change anything on your existing VPC infrastructure. We're adding a lot of routes to your existing routing table to all of your other existing on-premises and other cloud locations. So we're building those tunnels over your existing connections for you automatically.
So you're automatically building a VPN tunnel between AWS and the on-premises environment?
And even Azure, if you have an Azure infrastructure already. We don't care what sort of location.
Assuming that you have a Steelhead or SteelConnect or whatever at the other end to accept that connection.
Yes.
Okay, and so then it does the negotiation of the VPN keys and all that in the background?
Absolutely.
How does that inject routability into the rest of my environment, though? So, like, I've got a PC that, and I want to use an app that lives in the cloud. How does it?
So you already have a gateway which now knows to add these routes through our central console.
Okay, gotcha.
Right. So actually, I can show that to you real quick. So actually, let's look at what happens on AWS when I go to my VPCs. Actually, before we go to VPCs, let's go to my EC2 page. And I'll show you that because I clicked on that submit button and because I deployed it in HA, you'll see two instances of, if I'm in the right region, which I am. But you'll see basically two instances for my gateway and my Steelhead. And also, I just need to bring this down. Trying to, I see that there's 4 instances. Oh, thank you. So yeah, so there's 2 gateways and 2 Steelheads which are deployed when I clicked on submit. So moving on, this is really nice. It simplifies a lot of your operations in terms of bringing the cloud much closer to your network. Let's also look at what happens in the case of a direct connect connection or an Azure Express route. As you know, it's a private link from your data center or your colo to the cloud. What we've done is we've also figured out a way to build a tunnel from over your direct connect connection. So for example, if this is your on-premise location, this is your data center or your colo, and then you have a direct connect connection from your colo to over your VGW in the cloud, we can also build an IPsec tunnel over this directly. Why should you care? What's the big deal about actually creating an IPsec tunnel over this direct connect connection? Well, you should care because a lot of the SD-WAN features that all your on-premises locations had now suddenly are available to your cloud locations. And that's nice because when you want to actually dictate how your traffic goes in or out of the cloud, you're able to do that and use your dedicated connection over your private circuit in a much more efficient and a cost-effective manner.
What are you terminating that IPsec VPN on across the direct connect and the on-prem location?
Let me draw a cleaner diagram so it's actually better. So what actually happens is now if this is your cloud site, our gateway which sits here has one uplink which goes over the VPN gateway, which is VGW, and the other one goes over IGW, the Amazon router. So this has 2 uplinks. The downlink is going to be the same, and the downlink is what connects to all your app servers over here in your VPC. So anything that needs to be routed will now go through the gateway. And now, because this is our SteelConnect gateway, you can now select if you want to send that traffic over the IGW or over the VGW.
So I understand, but at the other end,
at the other end,
on-prem, what are you terminating that against?
So the direct connect terminates at a colo, and that's considered a site. And
so the IPsec VPN tunnel you said you put over the direct connect.
Yes.
What is the VPN endpoint on-prem that I'm connecting to?
A SteelConnect gateway also.
Okay.
Yeah.
And
both the ends.
If I put a direct connect in, or I put my own VPN using Palo Alto, Cisco, whatever, into cloud,
yeah.
and then I encounter the problem of how I want to stitch different regions together, can I use your solution to stitch them together and then route using whatever I've...
Yes, we call it classic VPN. We treat that differently from our what we call auto VPN, but you're able to create that. You'll only have to do it manually yourself.
Because then you've got the routes and you won't touch them for whatever region that exists in, but then you'll just stitch that into the rest of the network you're creating.
Yep.
Do you handle any headaches with MTU size as you can
continue to do IPsec tunnels and NCAP and such between all these different cloud providers?
If it exceeds the MTU size, we probably just fragment it and send it across just as a normal router would.
The operator is not going to have to go and troubleshoot that.
No.
It's all automatic. Okay.
Yeah.
What happens if you start to build a complex network and then you're starting to have to make routing decisions of where's the closest hop and things like that? Do you prescribe having a hub region to connect to, or how does this build out when it's fine when it's one or two regions?
Yeah.
But when I've got 10 and I add Azure and I've got on-prem, how does that play out?
Chris, I think that's a really good question, and that's a very good segue to what I'm going to talk about next. If you care, let me show you the workflow for what I just talked about, and I'll move on to exactly what you're talking about in a second. So if I wanted to, let's say, create a direct connect connection over here, I can choose to connect to a subnet VPC site. Actually, let's connect to one in Singapore. And it will then give me the option of selecting what encrypted underlay it wants to ride over. So here I can choose to deploy it. I'll leave this to off. And here, instead of this, I select Internet and Direct Connect. We have the same workflow even for Azure Express Route. And here I can choose my Direct Connect WAN and click here on Submit. So everything else taken care of. So now let's talk about what you're talking about. Let's talk about peering connections between different VPCs. It's a very helpful and a very useful concept. It's a networking connection which helps you move data from one private network to another private network. And that's great. Amazon allows you for that. But then there's an inherent problem with that. So let's consider this situation, which is, let's call this VPC A, VPC B, and these are both peering with each other. Great. Now, let's say there's VPC C, which is peering with B. Can I send traffic from here to here?
No.
No. That's an inherent problem because these are both private networks. We're not really routing. We're not really forming any tunnel. For all your traffic to go from one network to another, your traffic has to be either the source or the destination of that VPC that is traversing through. Of course, as Chris mentioned, we can form a peering connection between A and C also. The problem is that as you scale, when it becomes D, E, F, you can't go ahead and keep creating this full mesh of VPCs because A, it's very difficult to manage, and B, you're expanding the security exposure surface for your network. So if you have a bunch of application developers, anyone and everyone with a credit card can create a VPC and start developing apps in that, and you want all of these VPCs to talk to each other, it becomes very difficult to manage. So the solution to that is a hub and spoke model that we were just talking about. And we're able to solve the problem by actually, again, giving you the option to select which hub you want to select as your VPC, and select the spokes, and then we ride over that connections over the existing VPN peering connections.
Aside from solving for that particular case where you can't do the called transition routing or whatever.
Transit VPC routing, yeah.
Thank you. Transitive routing. Is there some other big benefit? Because I know in Microsoft Azure, you can do transitive routing across peered VNets. So if AWS decides to flip the switch and enable that, then you've lost your competitive advantage in that. So is there some other special sauce aside from solving this?
Well, the special sauce is what's inherent with our solution, which is the SD-WAN features that come with our gateways. Mm-hmm. So you're able to not just identify applications on first packet basis and not just able to select what path you want to go from one location to another, or maybe even apply some basic perimeter firewalls on allow or deny. And this is, so there's a lot of knobs and whistles that you can actually start enabling. I'm just focusing more on the cloud concept for this audience.
Right. So you're dropping a routing engine in your central VPC, so you can route packets outside of what Amazon allows you to do.
Exactly.
Encapsulated,
and Amazon also just announced in their reInvent last year that they're able to do VPC peering not just between one region, but also across regions. And I think that's great for us because now we can ride over the direct connect connection that I just talked about and ride over Amazon's backbone to route traffic across different regions. And that's excellent.
How about this coupled with something like AWS's sort of transit VPC design, which leverages something like a Cisco CSR?
Yeah. So that's one of the solutions. If you look at the page, even we are one of the solutions. The difference is that a Cisco CSR, you would only deploy their appliance at the hub and not at the spokes. And they create VPN connections, their own VPN connections between the different between the hubs and spokes. We ride over the existing peering connections. We even create the peering connections for you. And just because of the inherent properties of how a peering connection works, the traffic is much faster. It's of lower latency, and you don't have to pay the additional VPN cost that you'd have to pay to Amazon. And I can show you the workflow for that too. It's pretty straightforward. I can now that I already have a VPC connected in site A, I'm going to go ahead and connect to my VPC in site C. And once I do that, I have the option to deploy it. By the way, I hope we take a step back and look at what's happening as I'm talking through all of these. We have all these appliances deployed as I was talking, and there's a lot of log messages on the screen, which we log. And I'll go back to the dashboard to show you how far we've come. It takes about 4 or 6 minutes, so maybe you'll see still some tunnels being formed. But this is all the real network. So let's click here and deploy. I'm going to turn redundancy off. Here, I'm going to select Transit VPC. It gives me the option to select a transit hub. It's already seen that I have a appliance deployed in that region. I can click here and submit, and now it's going to do the rest of the work for me. So it's going to start manipulating all the routes. It's going to do all the IPsec VPN tunnels and all of that. I didn't have to do anything. Now, this is all really cool, but I'd like to wrap up by saying that a lot of this can also be even further automated and customized using your own scripts, because we have open REST API library on our website that you can go and call from your scripts and using your CloudFormation templates and customize it the way you want.
Do you have a Terraform provider?
We have a what?
A Terraform provider?
No.
No, okay. Because that would be really cool. Because I can use Terraform to build out my cloud infrastructure and also augment that with this as well to build out the WAN functionality between those regions.
That would be cool.
Yeah, what would even be cooler is have the concept of auto-scaling to the VPN connections. So on-demand VPN connections as needed. So just build the tunnels as needed. So SD-WAN solution that knows all of my AWS VPCs and regions and just builds the tunnels as on-demand as needed.
Yeah, you kind of see someone set up a new VPC and you just kind of inject into it to work at it. Yeah.
Maybe you have a CloudFormation template which knows to build VPCs and you tag it with a certain tag, and we have a gateway that just plops in the environment. We can totally make that happen, and it's probably even on the roadmap.
As a security person, that gives me the willies. Wait, if I put my security hat on, I'm just going, awesome, I just auto-owned myself, and now I've given you a way to do massive data egress.
Yeah.
Automatically, hooray!
So there's different ways you can handle that. Of course, you can restrict privileges and who actually can create those VPCs and how they create them.
Yeah.
And the second thing is we are an end-to-end secure solution where it's a strong swan IPsec VPN and
I mean, it has all the audit stuff in there as well, so you can see who created which VPN
Exactly.
and why.
Yeah.
So that would help after the fact.
Yeah. Are you managing the endpoint or the fixed IP address through a DNS? Your client have to fix its own IP address
in
each VM?
So yes and no. It depends on if you want to use our gateway to be a DHCP server or not. As I was saying before, that we don't manipulate anything on your existing VPC infrastructure. We're not actually even routing. We're adding routes to the routing table. We're still using Amazon's IGW, which is rerouting by adding those routes of your existing VPC infrastructure through our gateway. So if I went ahead and undeployed my appliances, we leave no trace at all. In fact, we don't even add a route to the internet, going back to the security aspect of what Justin was talking about. You will only be able to reach your other on-premises or other cloud locations in your network. If you want to add your 0000, then you add that yourself, and we don't change that. Does that answer your question? Well?
Yes and no, because you present something like a global solution for non-IT professional, because as I'm an IT manager, I really can manage my own VPN and my own VPS and VPC. So in my case, I really don't need this kind of service.
Yeah.
But I can understand that some of companies need it. But if this kind of company needs this service, what is touchy in VPC is to manage the DHCP, the fixed IP addresses, the VPN, and everything in the network. So that's why I'm asking to you if you manage the old virtual network or not. Because I think that could be a best practice to use your product to let you to manage everything. Because at one point we can be in a situation that we can know which responsibility is it, you know?
Yeah. I know that for our on-premises locations, we do act as a DHCP and a DNS server for everything on the LAN.
Yeah, but you're talking about on-premise situation, and we are in the cloud. So for me, the cloud and the on-premise situation
is the same.
Totally different for me.
It's different, yeah.
Yeah, this is different because in the cloud you have to manage the geographical data centers and to connect them by VPN. If you want to optimize your application, and if I well understood your product, this is the goal of your service. So if you stay in the cloud, even if you have an hybrid infrastructure, it doesn't matter. But if you stay in the cloud, I think you have to manage
the LAN side of the cloud too.
For this kind of client, it depends on your target. Maybe I didn't understand what is your target.
The biggest benefit of our solution as of today, as you mentioned too, is its scale. If you have 2 VPCs that you're very happy to manage yourself, if there's 2 VPN tunnels you want to build, the delta that we provide isn't significant, but we start providing a lot more value when the number of VPCs and the number of regions, and if you want to work across cloud providers, and you have a bunch of on-premises locations also, then that's where we have the maximum benefit.